Okay, in the third quadrant it is only tan which is positive. It means sine and cosine are negative. But as per our problem, we need an angle whereby the solution resulted is giving us a positive value. So in the third quadrant, we are not going to pick the angle formed at the third quadrant. The same to the fourth quadrant. The fourth quadrant, it is only cos which is positive. So generally, in our first rotation, our angles are 48.59, 131.41, 228.59, 311.41. That is first rotation. So we need to proceed and see how many values of x can we achieve given the limit from 0 to 360. So as we proceed, it means I'm continuing in my second rotation. It means in the second rotation, the angle in the first quadrant therefore will be 360 plus 48.59. So we are adding 59804. So it means as I continue with my second rotation, I must first of all land in the first quadrant. Landing in the first quadrant in my second rotation, it means the angle therefore will be 408.59. The same will happen even if I proceed to the second quadrant in my second rotation. It means if at all I have to proceed to the second quadrant in my second rotation, therefore the angle will be formed whereby I will have 540. I will have 540 minus 48.59. 540 minus 48.59. That gives 491.41. So it means in my second quadrant, second rotation, the angle formed there is actually 49141. Then let us just use the angles that we have actually calculated in the first quadrant, second quadrant, in the second rotation. Let's start with 408.59. So it means therefore I will have 408.59 will be equals to x plus 20. Now we are getting the value of x. This means it will be 408.59 minus 20 is equals to x. So let's see that. 408.59 minus 20. That one gives you actually 388.59 is equals to x. So this angle is beyond the limit we have, is beyond this limit. It means therefore we cannot proceed. We cannot proceed with the working of the values of x. Therefore, we are going to conclude that our answers will be, the values of x will be 28.6 degrees and 111.4 degrees, and this is where we stopped. We stopped at that point. So as per our first example that we have worked together, then we arrived at this point being our solutions. We arrive at that point being our solutions. So let's maybe go to the next example. Let's go to the next example. We come to the next example. So the next example, we have again solve for theta. solve for theta. The limits given 0 degrees less or equals to theta less equals to 180 degrees. So the problem given is sine 5 all over 2 theta is equals to a half. Is equals to half. So therefore, the same root applies here. The same procedure applies here. So here what we need to do first is to get the sine inverse. Sine inverse over half, which actually should give us 5 all over 2 theta. And when you look at sine inverse of 0.5, that is 30. So 30 degrees will be 5 all over 2 is equals to 5 all over 2 theta. And I've said before, reaching this level, draw a unit circle. Draw a unit circle, then divide that unit circle into 4 quadrants. So of course we have known how to count those quadrants, this being the first to go anti-clockwise. Therefore, we label the important details in our unit circle. So it means I start with 0 up to this other side. It means it goes up to half time. It means that will be 180 degrees. Completing it means it will be up to 360 degrees. So somebody can decide to continue. It means I've completed my first rotation and it is up to 360. If I decide to continue, it means from 360 up to this other half, then it means I'll be landing at 540. Then if I decide to continue second, it means it will be at 720 degrees. So let me just now use up to the second rotation. Let us use the unit circle up to the second rotation as per the values we have indicated. Let's come back. Let's come back, and even before we come back, then we can always label that here tan positive, sine positive, cos positive, here sine positive, tan positive, cos positive. Therefore, if I'm going anti-clockwise direction starting from 0, then I should know that that angle up to this point it is at 30 degrees. That is the first quadrant. The same value of 30 degrees can also be gotten in the second quadrant. And the angle in the second quadrant then will be 150 degrees. Then the sine 150 degrees, its value actually, another value can also be gotten in the third quadrant. In the third quadrant, it means we have said it is past 180, and it is past 180 by just 30 degrees. We do addition to 10 degrees. Then in the fourth quadrant, we are saying it is less 30. It is 360. It has not reached 360. It means it is before 360. Therefore, it is less 360 less by 30. That will be 330. 330 degrees. So we can continue. It means in my first rotation, I will have my angle in first quadrant 30, second quadrant 150, third quadrant 210, and fourth quadrant 330. If at all I need to continue, therefore, in my first quarter, in my second rotation, the angle will be 390. Second quarter, second rotation, it means the angle will be 510. It is 540 minus 30. That one I'm getting the angle in the second quadrant being 510. In the third quadrant, the angle will be what? 540 plus 30. Then that will give you 570 degrees. Then the same applies. In my fourth quadrant, it means I've not reached 720. I've not reached 720. It means the angle formed is actually less 720 by what? By 30. So it means the angle is actually at 690 degrees. So those are the various details in the unit circle as per the problem we have. Therefore, let's now come back to where we stopped. So we are getting the values of theta. of which therefore the values of theta, the theta value should actually always give us positive a half. So in the first quadrant, actually the angle will give us positive a half. It means therefore we start with 30 degrees, and 30 degrees equals to 5 all over 2 theta. So let's simplify this. So it means then 2 all over 5 by 2 all over 5. Then this will give you theta. Here it will give you 12 degrees. We have gotten our first value of theta. So it means we come to the second quadrant. Second quadrant, the angle found there is actually 150. The angle found is 150. Therefore, we will proceed. Therefore, 150 is equals to 5 all over 2 theta. Again, I simplify. So theta, this 60 degrees. So I have 60 degrees. I continue. It means I need to come to the third quadrant. The third quadrant, it is turned positive. Therefore, I will not use the angle formed in the third quadrant because it will give me a negative value. The same to the fourth quadrant. It is only cos which is positive. Therefore, I will not use the values there. Then, we need to check so that we fulfill the limit. So it means then I'm through with my first rotation. I'm through with my first rotation. So I need maybe to continue. It means when I'm continuing with my second rotation in the first quadrant, I will be at the angle 390. I will be at the angle 390. So therefore I will have 390 is equals to 5 all over 2 theta. Again I cross multiply 2 all over 5. So that is 390 divided by 5 times 2, 156. So it means up to that level I've found the angle 156. So logically, if I tend to proceed, if I decide to continue, it means the next value of theta I'm going to get will actually be beyond 180 degrees. That is sense that you can always pick out of the data that we have reached at, that is 156. So it clearly indicates that the values of theta will simply be 12 degrees, 60 degrees, and 156 degrees. These are the values of theta. Those are the values of theta. Then that is the point we stop at. That becomes the end of our working. So I would like to give work just relating to what we have discussed, relating to what we have just done. And there's basically two simple questions. There are basically two simple questions. Two simple questions. So the first question here will be, find the values of theta. Find the values of theta. Of course, the range is from 0 degrees to 360 degrees. No, the range is from 0 degrees less or equals to theta less or equals to 360 degrees. So the problem is 5 sine theta is equals to -4. Then that is the first question. Then the second question you will also again solve for theta. The range is from again 0 less or equals to theta less or equals to 360, and the problem is cos into bracket 3 theta plus 120 degrees is equals to root 3 all over 2. Yeah, those are the two questions that I want you to attempt. Then when we meet again, we shall go through them and verify the whatever